see Lindelof videos, log expressions, and critical thinking. And I think this should actually have been my first video because this is kind of how logs work, and you have to kind of think from a menu with log functions. So if I'm asked to condense this logarithmic expression, 2 times log 2x minus log y minus log, geez, Pete's, log 3 plus log 2 log 5, 2 log 5. Let's see if we can do this. First thing I'm going to do before I even start is make sure that we have something that we can at least attempt to look at. And the way you assess that is initially just by starting to make sure that your logs all have the same base, and they do. This is the log of 2x, which means this is base 10. Same thing, base 10, base 10, base 10. So that's all good. The next thing I'm going to do is this. I'm going to distribute this 2 into here and here. There's tons of ways to do this, so if you don't like this way, do it your own way, but this is what I'm going to do. I'm going to say this is 2 log 2x minus 2 log y minus log of 3 plus 2 log of 5. Now I'm going to start using some rules that I know about logarithms. And one rule that I'm going to use is this one. And the rule is this, that if we have log of x to some power, we're allowed to roll that exponent back and make it in log of x. Well, if you can do it that way, if you can roll the exponent back, we can also roll it back forward. And that's what I'm going to do. So I'm going to roll this to here, and this to here, and this to here. So let's take a look at what that would look like. It would look like log of 2x, quantity 2x squared, really important, minus log of y squared, right, minus log 3, right, plus log of 5 squared. Can you see what I'm doing here? I'm just really trying to be as systematic as possible. I'm going to clean these up the best that I can. For example, this would be log of 4x squared, because exponents are distributable over multiplication, minus log y squared minus the quantity log 3 plus log 25. I know it's a ton of stuff, but you kind of just have to keep hanging in there with it. So the next thing I'm going to do is this, that this says this says, right? The next rule I'm going to use is this one, and it says that log of x minus log of, let's say log of a minus log of b actually means log of a over b. So that's the rule I'm going to use, right? So I'm going to use that rule here. So I'm going to say this is log of 4x squared minus y squared, isn't it? Minus, and then the next rule I'm going to use, I can see where you're like, okay, there's another minus sign, we can do that. I'm going to hold on to that for a second. I'm going to simplify this inside. So there's this negative sign. The other rule that I know is this, that log of a plus log of b can be rewritten as log of a times b, right? So I'm going to keep moving here and do that. I'm going to say, okay, now we have log of 3 times 25 gives us log of 75, doesn't it? Log of 75, right? A is 3, B is 25. 3 times 25, 75. Right? Go back to that second row. We have to divide again. We get log of 4x squared over y squared divided by 75. You could leave it like this. You confuse the heck out of somebody. This is a complex fraction, isn't it? It's a complex fraction, so what you do here is you take this like this. Right? Complex fraction is if you have a over b over c over d, can be simplified as a over b times d over c. So this is a, b, c, and d. So I can rewrite this as log of 4x squared over 75y squared. Holy macaroni. That's a lot of stuff. This is actually a pretty complicated problem. Hope this is really helpful for you guys. Let me know. If you haven't already subscribed, please do. Thanks.